on pressure and work. So essentially, pressure, if you have differential of pressure, you have work. But why do we have that? Essentially, let's remember the formula of pressure is essentially a force per unit area. The area will be almost always constant. For example, this suction diameter and this discharge diameter will be constant. So forget about this. Now let's pay attention on the force. If we change the volume, that is the area or the height of something, we're going to have a differential of displacement. So for example, force times displacement is equal to work. Okay, so we have this definition I told you. Let's force, instead of having F, which is force, let's make it pressure. So we need to have pressure times area. We have it right here, and we have distance right here. So recall that area times distance of displacement or height will give you a volume. So we have this definition of work. So either a change of pressure or a change in volume will give you a, let's say, a work, and that means energy, mechanical energy. So normally, as I told you before, volumes will be fixed. So the only thing that can change is the change on pressure. The change in pressure, once again, means work, which means energy. So very typically, we will have either atmospheric and atmospheric. We will not have a differential. But let's say that not only that P1 is bigger than P2. This means that not only the height and the velocity will force the movement, but also the pressure. The pressure is going to push this area. You know, there is a pressure per unit area. Here is the area of the cylinder. So we have a force that pushes the substance. We want to model that. So for example, we'll have also another example here. We have this differential on pressure, pressure 1, and let's say this is pressurized. So the more pressure you have here, the more it's going to go up. You have a very high pressure, you expect a higher height of this beam. You have almost no pressure at all, you will expect something like this. So maybe you are getting the idea on how we are transferring pressure to height, or at least how the differential of pressure will give you the system a higher system or a lower system, because we are transferring energy, pressure energy, to potential energy. Once again, we have this system which is pressurized. It's going to push, and not only that, also the column itself, the potential, gravity, and well, it's going to move, and eventually it's going to increase. So the more pressure you have here, the more velocity you will expect in the beam right here. If you have a low pressure or even suction, if you had a lot of suction, you will expect actually the flow going backwards, which is not a common application, but it can happen. If you haven't checked out the complete course outline, you can always do it here. Course theory, you got all the 7 blocks that are included in this incompressible flow course. For instance, if you want to check out what's in the pump block, which is essentially pump block 5, you can check out pump types, system curve, pump selection, and pumping systems. So which units are we going to use in the equation? Well, recall pressure is essentially kilograms per, well, let's go. Pressure equals force by area. Force is kilogram per meter per square second, and area is meter, like this. So this meter goes away and we go and send this meter right here. So energy, remember the units of energy is kilogram per meters to the square power and to the second power, sorry, divided by the second to the second power. So if we want to force this, the only way to do that is adding, where is it? Right here, a volume. We need to add square meters, extra meters, so we add a volume. So I told you before, guys, this is joules, but since we use joules per kilogram, we need to divide by mass. And the problem right here is that we don't have mass, so we will need to divide by mass right here, and this is density. So thank God we have something related, and this is pressure. So we have pressure divided by density. That's joules per unit kilogram. And yeah, essentially, guys, is everything. We've seen this part right here and this part right here. Later on, we're going to see that if we send this to the left side, we can do this, and will be actually a differential. This is also known as either loss or gain of pressure. If you haven't checked out the complete course outline, you can always do it here. Course theory, you got all the 7 blocks that are included in this incompressible flow course. For instance, if you want to check out what's in the pump block, which is essentially pump block 5, you can check out pump types, system curve, pump selection, and pumping systems.